Okay, so in this video, we're going to do section 8.2 from AP Stats, and obviously I'm not going to go through all the slides. I'm going to go through the summary really quickly just to make sure everything's in here, and then please make sure you actually read the section before you get to the summary, because none of this will make sense to you if you don't read. So, a couple of things. The conditions for constructing a confidence interval about a population. You have three conditions that you typically have to meet. Is it random? Did you pass the 10% condition? And then the large counts condition. So those are the three things. Those are the conditions for constructing a confidence interval. All right. And then so this is going to be all about slide number 19? No, slide number 6. So this is slide 6. We're going to do that in slide 6. And then in the next one, in practice, we use a sample proportion p hat. That should be p hat in there. Okay, to estimate the unknown parameter p. Therefore, we replace the standard deviation of p hat with a standard error. And then basically what we're going to end up doing is taking, instead of doing the critical value, I'm sorry, not critical value, the statistic plus or minus the critical value multiplied by the standard deviation was replaced with the proportion, okay, the sample proportion plus or minus the critical value, and then replaced with the standard deviation using p hat instead of p, because we don't know what our population is going to be. Okay, where z star is the normal critical value. And okay, so this is going to be slide, I think slide 12, if I'm not mistaken. Let me double check that real quickly. Yep, that's slide 12. And then last but not least, how do you know how much of a sample size you actually need? And in order to do that, we need to know, first of all, our critical value, and then we need to know the, the population sample proportion. We don't know this. This is usually what we're going to find. Okay, how much of a large sample do we need? But we need to know what our margin of error needs to be. So this is going to be slide 19. Okay, so I'm going to do 3 slides for this thing. All right, so we'll start with slide number 6. Okay, presumably you've read, right? So, and then we're going to meet the conditions for this. So conditions for estimating estimating P, your population proportion. In each of the following settings, check whether the conditions for calculating the confidence interval for the population proportion P are met. And then I have to apologize in advance. The video will sometimes autofocus itself because I'm using a different dock camera. So if that happens, just bear with it. Okay. Number 1, in an AP Stats class at a large high school, there's your keyword, large, okay, conducts a survey. They ask the first 100 students to arrive at school one morning whether or not they slept at least 8 hours the night before. Only 17 students said yes. Okay, so we're going to need paper for this. Actually, no, I can work around it. It's a big enough piece of paper. Okay, pen and calculator. Okay. Alright, so the first thing is, for number 1, let's see, where do I want to work? I'll work on the side over here. Oh my goodness, this is difficult. Okay, so number 1, is this random? That's the question. And I don't think it is. I can't remember. Where's my paper? It's not random. Okay. Not random sample because you basically took the first 100 that arrived. So it wasn't random. If you wanted to do random, you should have just gone to the entire school. Not a random sample. I shouldn't say because. I should say this is a convenience sample. You conveniently chose the first 100 students to arrive at school. All right, so it's not a random sample. Okay, does it pass the 10% condition? All right, and then it should, I would think. So is 100, because you chose 100, so in this case n is 100, is that less than or equal to 1/10 of your entire population of the school? And that would be, what, 1,000 students? So that would be yes, passes 10%, since we have at least 1,000 students, okay, in a large high school. Alright, and then, so that's your 10% condition, and your large counts. Let's pass your large counts condition, and it should, I would think. Okay, let's see, large counts condition, p hat is going to be 17 out of 100, so that's 17%. So is n times p going to be greater than or equal to 10, and is n times 1 minus p going to also be greater than or equal to 10? Okay, and you can pretty much do that one yourself, and it should pass the large counts condition. Okay, but since it hasn't passed, okay, random sample, we cannot, okay, calculate a confidence interval. Okay, sorry if you can't see that very well, but that's what it says. Since it has not passed the random sample, we cannot calculate the confidence interval. Okay, that's number one. And then number two, let's see. Quality control inspector takes a random sample of 25 bags of potato chips from thousands of bags filled in 1 hour. Of the bags selected, 3 had too much salt. Okay, so let's see. We have random, yes, from, I don't know, from statement in problem. Pretty much, right? It says it's a random sample, so we're good with random. 10% condition is 25 going to be less than or equal to 1/10 of our entire population of bags, right? So thousands of bags that are filled in 1 hour. So that would be yes, since we have at least 250 bags of potato chips. Potato chips. Okay, and then last is large counts. Is okay. So what's our p hat? Going to be 3 out of 25, which makes it, I can't remember, 0.12. Okay, so in this case is n times p hat going to be greater than, oh, sorry, I should have done p hat on the other ones too. That was my bad. N times p hat going to be greater than or equal to 10. So is 25 times 0.12, right? Yeah, you selected 25 samples. Okay, it's going to be greater than or equal to 10, and is n times 1 minus p hat going to be greater than or equal to 10. So is 25 times, see, 25 times 0.88 going to be greater than or equal to 10. And in this case, you get 3 greater than or equal to 10. In this case, you get 22 greater than or equal to 10. Fails. Alright, so I guess it fails large counts. Does not pass large counts. Therefore, cannot construct confidence interval. And I'm going to abbreviate this because I'm running out of space. Okay, that was slide number 6. All right, and then I'm going to do slide number 12 and 19 in a different video. So that was the first one, and then look at the other 2 videos for the other 2 slides.